Assalamualaikum warahmatullahi wabarakatuh. My name is Zamir Ali bin Shuariman. My metric number is CE1900228. So our group member is Akif Rushaidi bin Azim and Amir Akmal bin Zuhaili. So we are from group A2.2 from section 2. So in this presentation we will present about the power factor correction. So in this presentation I will explain about what is power factor and what will you do in this activity. So what is a power factor? Power factor is a ratio between the real power, which is stand for P, and the apparent power, stand for S, drawn by electrical load. So it is measured of how effectively the electrical current be converted into a useful work output, and more particular is a good indicator of the effect of the load, current, and efficiency of the electrical supply system. So before learning about the power factor, the thing first we should understand is the power triangle and their components. So active power, which is stand for P, to find the active power, which is voltage time current time cos theta, their unit in watt. For reactant power, which is stand for Q, V times I times sin theta, their unit is VARS, and the apparent power is stand for S. To find the apparent power is V voltage times with the current, so their unit is VA. So there has a mathematical method to find the power factor, which is cos theta or equal to active power, which is P divided by apparent power S, to get the power factor. So this power behave differently depending on the load. So there's no Q at a resistance load, but it has a positive QL at 90 degree for inductive load and negative QC at 90 degree at capacitive load. So the angle different between voltage and the current cause this variation. The load consume all the P, but all the Q oscillate between load and source, because the angle of voltage and current between 0 to 90 degrees. Power factor also varies between 1 and 0. Okay, next I will present about what will you do for this activity. So first of all, we're understanding the power factor correction method first, with all the theory and the calculation method. After then, as required, we need to reduce the power loss and improve efficiency, as well as the current carrying capacity of line and voltage regulation, which means the power factor must be improved. So furthermore, end user can reduce their additional billing. The acceptable limit for efficient electricity use is a power factor improvement of 95%. So the power utilities required to be close to unity, but 90 to 95% is acceptable. So since the power factor correction take place by adding a shunt capacitor, therefore QC cancel out the QL to maintain the angle different as nearest to 0, resulting which is power factor toward unity 1, because the cos theta is equal to 1. And then our task to do in this activity, where we calculate the value of QC, which is a compensating C component, to eliminate the QL L component to achieve a 0.95 of power factor. And then we calculate the capacity reactant SC and QC for data as well as a star combination, to observe whether this calculated value can be applied or not to achieve 0.95 of power factor. And then after we done all the calculation, we get the value, we insert all the data or the value that has been calculated into the table given in lab activity. And lastly, for the activity 2, which is a question, we look or we observe the activity and research for the advantage of power correction. So that's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Akif Rushaidi bin Azim and my metric number is BE4030184. And this part of this video, I'll be talking about the connection of the system for our laboratory session. Here we have our supply unit, which we have our switch, our circuit breaker, our digital measurement unit, and our analog measurement unit. So what we need to do first is we need to connect our main supply to our circuit breaker phase by phase. So we start with red phase, yellow phase, and blue phase. And after that, from our circuit breaker, we can head to our load, red phase, yellow phase, and blue phase. And after that, we can connect it to our analog measurement unit. So red phase and yellow phase. This will measure the voltage line to line from red phase to yellow phase. And next we need to measure our line to line voltage between yellow phase and blue phase using our digital measurement unit. And then we need to connect our circuit transformer to our measurement unit to measure the current in series. Okay, after we've done the connection to the system, then we can proceed to connect to our resistive and inductive load. So on the left side is the resistive load and our right side is our inductive load. So the connection is from our system just now, red, yellow, blue, and neutral. So we can proceed to connect red phase to our resistive load and our inductive load, yellow phase, and then blue phase, and then finally our neutral. So after we've done our connection here, we can measure our power factor before we've done our power factor correction. When we want to do our power factor correction, we need to add our capacitive load. So in the next slide, we'll be connecting our capacitive load. So this is our capacitive loading unit. So we'll proceed our connection, and red, yellow, blue, and neutral will become from our supply just now. So the connection will be like this. So red, and then yellow, and then blue, and finally neutral. So this is our connection when we add our capacitive load when we want to do our power factor correction. So that is all from the connection. That's all from me also, and thank you.
Assalamualaikum. My name is Amirul Akmal bin Zuhaili and my matrix number is BE40301. So next is the expectation on power factor. So as we can see, this is table 2.1. This is the step for switch inductor and resistor. This is I9 and power factor. So both of the value is been given, and we also know that the value for our voltage source is 415. So from that we can simply calculate for our power in watt, right? Here we can see that when the I line increase, the power factor will decrease, right? So the desired power factor or the power factor that we want for our improvement is 0.95 for all, right? So in order to do that, of course we need to add certain amount of capacitance. Alright, so let's look at step 1 for switching 1 to 1. Alright, so our initial power factor is 0.85 and our desired power factor is 0.95. So we improve from 0.85 to 0.95 by adding 622.4 var or as the capacitance value. And then if we look at another case or step when the switching 5 to 1 for inductor to resistor, our initial power factor is 0.56 and the desired power factor is 0.95. So when we improve from this value to this value, we add 2733 var, right? And we can observe that the lower the power factor, the higher the amount of capacitance that need to be added, right? So as our result, the expected power factor, of course, it should be 0.95 or above, okay? Because why? Because the desired power factor is 0.95, which is this is our objective, okay? So the expected power factor should be same or more, right? And it cannot be less, right? As a conclusion, power factor play a significant role in our system. The power factor is also used to measure how effectively the electrical power is being used. So a high power factor means that the electrical load are utilizing the electrical power effectively, while a low power factor indicate a poor utilization of the electrical power. So power factor correction is one of the methods that used to improve the power factor, and it is beneficial to our system, right? So first, it increases the efficiency of the system. So we know that it reduces the power losses and also the current losses in our system. Therefore, the power quality is increased and the efficiency is increased as well, right? So number 2 is it reduces the voltage drop, right? So in poor power factor, the voltage drop is high, okay, is high. So the load or the equipment will receive less voltage. So when we do the power factor correction, it helps to reduce the voltage drop at the conductor and our load or our equipment can receive a sufficient amount of voltage, right? So the third one, or the last one, is the safe electricity bill, right? The power factor also used to determine the monthly energy consumption, right? So from that we know whether we need to pay more or we need to pay less for our electricity bill, right? And the utility also charge a penalty fee to any customer or consumer that has power factor less than 0.95 in this case, right? And then the only way on how we want to avoid that from we want to avoid from the additional fee is by improve our power factor. So that's all from me. Thank you.